Okay, now that you've had a chance to graph your data, I don't know exactly what it looks like, but it may look something like this. So you've got a little bit of upward movement down here at the bottom, and then it really takes off, and then you've got a little bit of sort of flattening out up here. You've got the temperature on the y-axis, and you've got the time on the x-axis. So I would suspect that your graphs look somewhat like that. When this is done and it's really controlled and all the variables are taken care of, we should end up with a graph that looks more like this one that you see in front of you, where basically the water temperature does not change while the water is a solid. During that time, it is melting. So all of the heat energy is going into melting the ice, and the temperature really doesn't change very much. So we get this flat or horizontal spot on our graph. Then, once all the water is melted, right here, all the heat energy now can go into warming up the water. So the temperature constantly changes and gets hotter and hotter and hotter until it reaches that point of boiling, when now all of the heat energy is simply going into boiling the water, and so it will remain again in this horizontal area until as long as it's boiling, and then it's being converted into a gas. Now the gas itself can have additional heat energy in it, and its temperature may go up, but the liquid itself, as it's turning into a gas, will pretty much stay at that boiling point of, ideally for water it's 100 degrees. Now I know your graphs don't look exactly like this, but they look pretty similar to this. In your book on page 9, there's a diagram that talks about phases of matter. On the left-hand side right here, you can see a diagram of a solid where the individual atoms of the material are packed really, really close together. They are moving themselves, but there's very little movement between them because they're packed together. The middle picture is a diagram of what matter looks like when it's in a liquid stage. They're able to roll around each other, they can move back and forth, but there's still some space, they're still fairly close together, okay? As more heat energy is added to the liquid, then those molecules get farther and farther apart. So there's huge distances between them as they become a gas. So this is one of the ways that we represent what a solid looks like, what a liquid looks like, and what a gas looks like. Okay? Make sure you have that information in your notes.